Hi, this is a short presentation about PGmacs, which is a browsing and editing interface for Postgres databases. My name's Marsden, and I'm the developer of this Emacs Lisp library. PGmacs was inspired by SQLite mode, which is a great feature available from Emacs 29 onwards. It allows you to view and modify SQLite databases you might have lying around. It's a really great feature. It would be even better, however, if it were able to use a real database. And I happen to know that was possible because a few years ago I wrote an Emacs Lisp library, pg.el, which implements the wire protocol used for communication over the network between a Postgres client and the Postgres backend, the Postgres server. I've included here an example of what it looks like to use this library. You connect to the database by specifying the database name, your username, your password, potentially the host name that you're connecting to. Once you're connected, you can then execute SQL statements, for example, to create a new table, to insert values into that table, and to count the number of rows in a table. And pg.el does automatic type conversion to and from Emacs Lisp types and Postgres types for you. Probably the best is to jump straight into a demo of PGmacs. When we connect to a database, we see up the top of the buffer some information about the backend that we're connected to, some version information, and the total database size on disk. There are some shortcuts to some commands we can run on the database, and there's a list of tables that we have access to, with, again, meta information about their size on disk and their owner. We can enter a table by pressing return. Here we again see some meta information about the table, such as the list of columns, the SQL type of each column, any default that might be present, and any SQL constraints. We see any indexes that might be present on this table, and then we see the list of rows of data in the table. If we see any information which is incorrect or incomplete, we can easily fix it by pressing enter again. And this updates the information present in the database. PGmacs shows us this in the mini buffer. It has updated one row. We can look at help for the key bindings that are present in this type of buffer. If we scroll down, we can see that we can upcase the value of a cell with meta u. Let's try that out. Okay, here we have updated the value of the cell in the database. We can now lowercase it and we can put it back to the initial title case of the value. We can also run a shell command on a cell value to count the number of characters, for example. We can run a shell command with a prefix argument, which updates the value in the database with the output from the shell command. So that has updated the database. If we do that again, that will reverse the value. If we come back to the list of tables, we see that there is a table which is called delete me. We can try renaming this table with R. We can look at what is in this table. Okay, there is only one row of information that doesn't seem very important, so let's delete that. Let's now delete the table with del. PGmacs asks for confirmation, and we've deleted the table. Now, when we have a big table with a lot of data, PGmacs is going to show us the results paginated, so we can go chunk by chunk through the table. We can implement a where filter on the rows to only show the rows that match a certain SQL clause. So, for example, here we have some temperature measurements. We want to focus on measurements that are more than 40 degrees Celsius, for example. Okay, we have now filtered on a certain number of rows. The filter is shown to us just up here. And we see here that we have some values that look anomalous. There's one 140 and one is 61. We probably want to delete these. They represent errors. We can mark them for deletion with D, and then really delete them, expunge them as in red with X. We can export this table in CSV format, thanks to this little button up here. Here we have our table conveniently formatted as CSV. We can also export a particular row to JSON by typing J. And let's look at what that looks like. Okay, here's the JSON for one of the rows in the table. Now let's look at a table that contains an attribute of type HStore. This is a Postgres-specific key value map. And then the attributes column is of type JSON, which can be stored natively in Postgres. It's possible to edit these values using a widget-based interface by typing W. And here we have a convenient interface for modifying these types of values. Likewise, with a JSON type parameter, we can update using a widget-based interface. Let's connect to a different database. We do that with Metex PGmacs and telling it our username and password. Here we have the list of tables present in this database. PGmacs has some support for running the SchemaSpy utility, which generates a graphical representation of the relationships between tables in this database, which can be useful when you're discovering the database. Here is the SVG that's output by this utility. This is a test database containing information about a digital media store. It has a table with information about the tracks that are available. And if we look at this table, we see that we have the name of the track, a reference to the album ID. This is a reference to a foreign key, a key in the table which is called album. Now we can follow this foreign key reference simply by pressing Enter. And here we find it's the album called For Those About to Rock. And in the same way, here we have a foreign key reference to the relevant artist, which we can follow. That's, of course, AC/DC. And finally, PGmacs has some convenience queries that allows us to list the procedures which are defined in this database. Here we have the built-in procedures, mostly used by the PostgreSQL extension. We can also display some more information about our backend. Here we have the list of extensions which are available. We can load one of these extensions if we have the rights to do that. Here we've loaded the relevant extension. We can show some information about the Postgres settings also. And update them if we have the rights to do that. Now I'm preaching to the converted, but Emacs is a really great application development platform. It's currently around 3,000 lines of code. A first point of comparison, PGCLI, which is a text user interface for accessing Postgres implemented in Python, is 17,000 lines of code. PGadmin 4, which is a well-known Python GUI for administrating Postgres databases, is almost 500,000 lines of code. And dbeaver, implemented in Java, is almost 1,000,000 lines of code. And developing things on Emacs, you get for free portability between different platforms. As I'm showing you, it works great on Linux, which is where I developed this library. It also works perfectly in the terminal, except for some of the functionality I showed, which requires SVG support. It also works well if you're into that kind of thing on macOS and on Windows. And it even works perfectly on Haiku, which is a free BOS clone. Emacs is actually really pretty on this operating system, so congratulations to the people who did the port there. Now, of course, the main advantage of building on the Emacs development platform is that the application is easy for the user to extend. To illustrate that, previously we were looking at a table of temperature measurements. Imagine we want to highlight rows in this table which look anomalous, where the value looks a bit extreme. That's quite easy to do with a bit of Emacs Lisp. We define a function which, if the cell value is bigger than 40, is going to display it in a face which has a dark red foreground. We can now register this display function for the measurement column in the temperatures table. And if we reopen the table now, we see that the anomalous measurements are indeed highlighted in red. Another example, imagine we have a table which contains image data. There's a column which is of byte A type, which contains images in binary form. We can display these inline PGmax as follows. We create an inline image display function using Emacs's image support, and then we'd register this function to display the image column in the inline image table. If we now reopen the inline image table, we see the images are displayed inline. And as a final example of customization, here's how to bind a key to a specific function, row list display. Let's define a function that does a .go lookup for a particular value in the Emacs web browser. We can define a function which does a fun call on the cell value for this DuckDuckGo lookup function. And finally, we can define a key, the capital D key, in the row list map, which calls this function that does a DuckDuckGo lookup. And now if I'm browsing information in a table that I want to do a web search on, I can use my D shortcut and see some web results concerning the cell value. So to conclude, the source and installation instructions for PGmacs are available on GitHub. It requires Emacs 29. There is a pre-built container image which you can use for testing. That's a Docker image. It only works in terminal mode. And of course, that's a recommended way of testing some Emacs list code that you load into your Emacs before having read it. It works with any recent version of Postgres over the past 10 years, including the latest release, Postgres 17. It does work with a certain number of databases that are compatible with Postgres, such as ParadeDB or TimescaleDB and Ivory SQL. However, it doesn't work with all databases that claim to be Postgres compatible. It doesn't work, for example, with CrateDB or with CockroachDB or some others that you see listed here. The reason for that is that these databases don't implement the system tables that Postgres queries to obtain information about the columns present in a table, the size on disk, the ownership of tables, etc. PGmacs supports TLS encrypted connections to the database, as well as local Unix socket connections. And in terms of stability, I would classify it as beta status. I do use it myself in production on some not very important data. Really, it works quite well. Thanks for your attention.